Right, hey everyone, so it's pretty much the hottest day of the year, and so I'm going to shelter in the workshop, use some of all the solar power that's available, and we'll start making the new turbine. Now the reason I need to make the new turbine is because this turbine is going to have two big adjustable spear valves, and they've got big nozzles, and the other turbine, the spoons are too small to take such a big jet. So we need to make a new turbine, and you know, I made that one when I didn't have all the tools and equipment I have, so this one's going to be better and more efficient. And so yeah, the first thing to do is cut out all the parts I need on the plasma table, extreme CNC plasma table. I've got all the parts already from the time I built it before. So there's all the various parts. It's all ready to go. We've built up some air, and so yeah, let's get cutting. Right then, let's see. Air compressor off. That on. Zeroed. Let's turn that off, and I'll start slowing it down a little bit just in case. Speed it up if we need to. Let's go. So that's the turbine all welded up, or the housing at least. So the next job is going to be to actually make the turbine itself. Then we'll mount the permanent magnet alternator, and then we'll get the nozzles fitted. We'll attach them, and then we'll be good to go. So yeah, let's get the turbine disc cut out, we'll make the boss, and then we'll mount the permanent magnet alternator. Right, so got the disc cleaned up a bit, drilled the holes out. Now it's mounted in the lathe, ready to bore this hole to size, because obviously plasma cutter's not that accurate, so we've got to finish off all the holes and dress everything. So yeah, let's get that bored out in the centre. I mounted it in this little jig to keep it straight, because obviously I can't clamp to this. Right, so there we go, there's our disc. So obviously I use the plasma cutter to bore the holes so I know where the locations are, and then I just drill them out, and it just has a little tidy up, bore out the centre, grind the edges a little bit, and yeah, come out quite nice. So the reason for this shape is because it's not actually necessary for the amount of power I'm doing. It could just be mounted on bolts, but I just think it's cool. It just makes a really nice job of it. And so the spoons actually sit in there, and that back bit supports the back of them so that they can't crack off, which at this power they wouldn't. I think with this design like this, these can do like 5 kilowatts, 5-6 kilowatts. On the bolts they're rated for like 2 kilowatts, so even on the bolts it'd be more than what I need, but I just like it like this, so that's what I'm going to do. So let's start mounting these on there. So procedure for getting these on here is spread them a little bit and get that started. Take that out. Wiggle them in place. Right, one down. So as you can see, the water comes in here. This is the sharp edge. It hits into this spoon, changes direction, and that's where the energy comes from, and squirts out in that direction out the bottom. So yeah, that's one down, 16 to go. I'll get a few on and we'll come back. Right, last one. Most tricky one usually. Okay, not too bad. So that's another job done. So the next job is to make the boss, which holds this and connects to the alternator, which is a good long day's worth of work making one of them, at least a day. Got to machine the boss itself, bore it out, end cap for it, 6 holes which hold it to this that need to be drilled and tapped. So relatively time consuming process. It's like I say, a long day making one of them. So then that's the next job. And then it's drilling in nozzles, and then it's fitting. So we're getting there. That's another phase done. So there's a completed turbine. So nozzle in this one, nozzle in here, and one nozzle in this way. Yeah, that's how they work. Right then, it's time to start machining the boss. Right, so that there wasn't actually the spigot that will hold this when it's in the end product. It's just one to locate it so I can get all these holes, because it's plasma cut. The holes aren't going to be absolutely perfect, and so I have to match the holes to this rather than do a hole pattern. It's just plasma cutting is very good, but there's limitations to it. And so I've done this really tight, so it has to be a pretty tight fit on there. And then we can mark these holes out and then get them drilled. And then we can cut a cap off and all the holes will line up. Right, there's our hole pattern marked off the turbine, so we know they're in the right place. So we need to drill them. Once they're drilled all the way through, we'll cut the cap off that we need, which bolts on it, and machine this bit off and square that up. And then we'll still have our holes marked through. Then we'll drill and tap those in the cap and everything will fit together. That's the plan anyway. Then we've got to turn it around, bore this side out to fit the shaft of the alternator. Right, holes are drilled, so now I'm going to machine off this spigot, so I don't need this anymore. That was just to locate everything. And then we'll machine a cap off, and then we can transfer these holes down, and then it'll all line up. So just getting these holes tapped, which is a daunting job. Try and keep them straight and not break a tap, because if I break a tap, that's game over. Start again. So we've got a brand new tap in paste. Give us every chance we got. This is the last one to do, so now I've got to bore the hole out the middle. do all this stuff first, because if these go wrong then I'll have to start again. At least I haven't spent time boring the hole. Almost there. That's it. Okay, we are getting somewhere now, so bored the hole out, and it's a lovely fit. Listen to this. Perfect. Perfect fit, that. Zero play. Excellent. Right, so I've just machined these two holes in the boss. Now, these little two screws which I've just machined, hope you can see that okay, it's in focus, and they go in these holes, and the little recess in them goes in this keyway. Obviously it'd be better to have a proper key, but getting a key machined into there is really a significant job, and you need specialist tools, which I don't have, so we'll go with this. I've used it in the past, it works very well. It wouldn't work for a really high power system, but this isn't a really high power system, so it will work. So that is all as one, and then obviously there's also a bolt that goes down through the middle here, which adds a significant more amount of friction, which is also good at holding, but those would easily hold what we're doing here, because it's only about 700 watts and it's going to be spinning at 800 RPM, so it's a tiny amount of torque. So then next we put this on, this way up, get our holes aligned, which is there. And then it's our cap, which is also marked. There's the mark on there, so that one goes there. And then it's just a case of putting all our bolts on. There we go. Haha, well happy with that. And that's the completed turbine and boss with it back off. So mount that to the turbine housing and then obviously mount that to it. Yeah, well pleased. No mistakes. It's very easy to make a mistake doing one of these. Right, okay, mounted the alternator. I didn't film it, it's just 4 bolts. So housing's now spinning on it. So now we get this. Turbine slides down there like that. So that's on, that's mounted, it's done. So next job is fitting the nozzles. Right, hey everyone, so new day. Today's job is to get all the nozzles fitted. So in the last video that I did of building a turbine, you would have seen the full completed spear valve nozzles that me and my friend John have been designing. I haven't got full completed ones here at the moment. I've just got the bodies, because I'm doing the bodies and John has been machining the spears. And now all of the spears and everything, they're so time consuming to do on a manual machine that the ones we've made, the new prototypes, which we made 2, are going to get taken to a place where I'm going to see what the cost is to get the spears machined, CNC machined, because it's just not worth, like if I was to do it, it's going to take me like all day to do like 1 spear, and it would make these too expensive. And so we're going to do that, but what it means is I've only got the bodies here, I don't have the bits, so I'm just going to mount the bodies and everything to get everything in the right place, and then when I've got the completed ones, I'll mount the completed ones. Just drilled a hole for the spear, Now, something I've always struggled with is the nozzle alignment. And so generally what I do is I drill a few little holes. I've got some drilled here somewhere. Yeah, just here. So I drill a few holes, and I use this little thing. It's only basic little thing. It's just a piece of welding wire with the with the wire square to this bit of steel, and I drill a few little pilot holes, poke this through here, move you around so you can see. So then poke the wire through and hold it flat against the housing on the outside, and then I can aim the jet where it needs to be. Now there's always a bit of a compromise. Maybe if I go like that, you'll be able to see. Can you see that? Okay, yeah. So let me get it square onto you. So there's always a bit of a compromise, because that jet now, obviously the jet itself is going to be like 20 millimeters. So this is only just showing us the center point of the jet. So that jet now is being split in half, just under half, with this one, with this spoon, this one, and maybe a tiny bit on this one, but probably nothing on that one. And it's just going to start to split the jet on the next one. So as that comes round, obviously I'm only spinning the housing, so I can't spin that at the moment. As that comes round, it starts to interact with the next one. And now we're splitting the jet in the center of that one, splitting the jet into the middle of the spoon on that one, and maybe just glancing that one, which is, in my experience, what you want. So that's what I do. And so I've just drilled this bigger hole round. Can you see that? Yeah, bigger hole there. And so now I've got my spear valve housing, and I've poked just a brass rod through it just to check everything. And now if I poke the spear valve through there, and we'll do the same thing. You can see this bit of brass is only 12mm, and the jet's going to be 20mm. So, but you get an idea of nozzle direction. So that one's going to be just glancing this one, which is a bit too far over. It's going to be hitting this one just right, and not just glancing this one. And as they rotate, we're not hitting any of the edges, and we're mostly getting in the center line. Now there's always a compromise with this, which is why a turbine can never be 100% efficient. You're never going to get it 100%, because there's always going to be a period in that rotation where you're not hitting it perfectly. And so it is a compromise, but I think that is about the best location. It doesn't matter how many studies and things you read on this, they're all different. And all the different spoons, all the different nozzle diameters, it all changes the jet location. But to me, that looks right. Right, hey everyone, so you join me down at the powerhouse. I was hoping to just fit this turbine straight in the old powerhouse, but the floor is rotten. So I've had to rip all that out and put new floor in, which I've done. So we've got the new floor and we've got the new turbine fitted. Well, it's all got to come out yet. I've got to change the nozzles. I'm just getting all the hoses lined up. So I'm just getting this hose on this one. So yeah, join me as I try and get that in place. So we've got this hose. This is the original turbine, or the original pipe hose. And this one's taking a bit of a curve, because I don't mind this one having a bit more loss than this one, because this one's got a bit more head, so it helps evening it out. But I've worked it out, and it's only about 1% loss anyway in this curved pipe going to this nozzle. And this one, I've orientated this spear so that this pipe pretty much goes straight into it. Makes it a little bit more difficult to adjust this, but it's not too bad. And any other orientation, I'll be reaching over the turbine to adjust. So I think this is the best layout. So yeah, I'm just going to start getting this fitted on here. I've got a bit of an issue though. and that is that the foundation of this little turbine building has started to rot. And annoyingly, it's literally just in one corner. This is a bit too tight in here. Right, I've got a clip that fits. So yeah, as I was saying, I've got a bit of a problem with this hydroelectric building, and it is that the base of it is rotting in one corner. I always knew it would rot eventually because it is made of timber, but it should have lasted another 10 years or so, because this corner, that corner, the corner you're in, and the cross pieces, they're all solid. They're actually showing no signs at all of deterioration. This one corner here is going soft, which is really annoying. It must be just an inconsistent bit of timber, or a bit of timber that already had a bit of rot in it, or a bit of fungus in it or something, because everything else is solid. And I don't think I can really get in there to repair it. And so I think I'm going to have to take this building apart and put a new base on it at some point. It's going to last a couple more years, so we don't have to do it straight away, but it's going to be a job needs doing. But yeah, it sort of got me thinking, you know, it's a bit disappointing having to redo stuff, and you think, oh, why didn't I just, you know, do it differently and just do it right from the start? But you have to give yourself a bit of leeway with stuff like that, because when I built this, I didn't have a lot of money or tools or the skills I've got now. And, you know, you do things the best you can at the time. And I knew that at some point I would have to redo it. That was inevitable. But, you know, I worked out that it will probably be a fairly long time from that point that I did it, and I'll get some use out of it. And at the time, you know, I didn't have a sawmill. I didn't have all the tools I've got now. And you just got to not give yourself too much of a hard time if you've got to redo something again. You know, once your skills, ability, money, tools, resources changes, you know, and it has now. And so I'll probably, in the next couple of years, knock the cob out of these buildings, because I only cobbed this because I didn't have any money at the time, and timber's really expensive. And, you know, now I've got the mill, it's more available to me to use timber. And so I knock these cob walls out. They can just knock out onto the ground because it's all just cob. Take the building apart, take it off, put in maybe a stone foundation down here, something like that, and then put the building back on top of it. It's not a huge job. It is a pain in the arse, but like I say, I'm not going to give myself too much of a hard time about it. It should have lasted a bit longer than it did, but it hasn't, and so I shall have to rebuild it. Right, that goes on there. That's okay. Might spin that clip round, maybe. Don't know, we'll see. So unfortunately, you're not going to see this running because I haven't got the valves, they're not finished yet, and there's no water yet in the streams. So we're just going to get it installed, and I'm not going too over the top with the installation either, because as I just explained, it's all going to have to come out within a couple of years. And when I do it, I might make the building a bit bigger. I don't know yet. We'll see about that. Okay, yeah, it's really confusing why that one corner's gone soft, because everywhere else is still rock hard. Well, wood hard at least. And there's no rot in this at all. That's the back one. Yeah, that one's just absolutely fine. Yeah, the front one is fine down here. But then this end, see, it's going quite rotten on me, and I have checked, and it goes in quite far, up to about here. This section's just gone rotten, where everything else is solid. But never mind. We've got our turbine fitted, our hoses on, and I've got the plug wired in. So yeah, that is all I can do for now, until I get the nozzles. Yeah, I think it turned out nice. It will look exactly like that. It's just that those will have nozzles on them, and the spears, at the moment they're just bodies. Yeah, also added pressure gauge back there, which will have a upright pressure gauge on it, face this way. That's for that one pipe, and then we've got our pressure gauge over here for the other pipe. This one's the one we've added, which is going straight in to that spear valve. This is the original one. So hopefully this one will do about 400 watts, and this one's going to do about 300 watts from 2 different intakes. Alright, so that's going to conclude this video for now, until I get those 2 nozzles back from where they're currently being made and machined. I can't really change that and get that all buttoned down and screwed down, and even if I could, I mean, this is the current water situation. It's basically all dried up. This isn't the stream that feeds it, but you get the idea. So we'll have to wait until we get some rain, wetter weather, and then we'll test it. Hoping for 700 watts total, 4 out of one, 3 out of the other. We'll see. Yeah, once there's some rain, we'll come back, fit the nozzles, do the testing, and yeah. But other than that, this is concluded for now. Next video will be the cross-flow turbine system I've been working on. All right, hope you enjoyed it, and thanks for watching.